Alright, this lesson is on decoding the resistor color code. So first let's review a little bit. What is resistance? So a good working definition of resistance is it's any device that uses voltage or resists the flow of current. So a hair dryer, a toaster oven, anything you plug into the wall has electrical resistance. Well, when you're designing electric circuits, it's helpful if you can pick up a device that has a very specific amount of resistance, because you want to be able to design circuits that do useful things. And so you want to be able to finely control the amount of resistance that's being supplied by the various parts of your circuit. So you make these devices. Let me show you what they look like. They look like this. There's two metal leads and a barrel looking thing in the middle. This is the business part of the resistor, and here I'm zoomed in, so these things are actually pretty small. You'll see one a little bit later when I measure the resistance using a multimeter. But these things don't have polarity, so it doesn't matter which side gets hooked up to higher voltage or lower voltage. You could flip this around, it doesn't matter. But these things are designed to supply a very specific amount of resistance. And so it's important to know how much resistance your resistor is providing to your circuit. And in order to figure that out, you've got to decode what these color bands mean on the cylinder, the barrel part of the resistor. All right. So in this case, this resistor has 1, 2, 3, 4, 5 differently colored bands. It's a little bit hard to make out what the colors are here in this video. So let me write down what the colors actually are. And also notice that this last band right here, and this is also a little bit hard to see, but the spacing from this band to... Alright, I just took a phone call. I can't remember what I was saying, but I think I was talking about the tolerance band. It's a little bit further away from the other bands. The spacing between the tolerance band and its neighbor is a little bit greater than the spacing between the other ones. Now I have lots of circles on here. So what are the colors here? The colors are blue, gray, black, brown, and the tolerance band is also brown. So there's a table you can look up that shows you what digit each of these colors represent. Well, blue is 6, gray is 8, black is 0, brown is 1. So we got 6, 8, 0, 1, and the tolerance band is also 1. So what are these? How do you put these numbers together to get a resistance? Well, these first three numbers are just numbers. This last color band, not including the tolerance band, is called the multiplier. So it is actually representative of a power of 10. So the resistance of this resistor is 680 times the multiplier, 10 to the first power, because you have brown, which means 1. It's 10 to the 1, 10 to the first power, which is 6,800 ohms. Now the brown tolerance band here is brown is 1, is telling us that we should expect the resistance of this resistor to be 6,800 ohms to within brown 1 means 1%, to within 1%. So 1% of 6,800 is 68. So we should expect the resistance of this resistor to be between 6,732 and 6,868 ohms. Let's measure what the resistance actually is with a multimeter. Now keep in mind the multimeter has a degree of uncertainty as well, but let's see what the multimeter tells us the resistance of this resistor is. Alright, so here's my multimeter, and I'll set it to right here to measure resistance. And here's what the actual resistor looks like. And I put the red lead on one side of the resistor, the black lead on the other side, and it doesn't matter which side goes to which. and my multimeter is telling me that this resistor is 6.66 kiloohms. 6.66 kiloohms. So the actual resistance is 6,660 ohms, according to the multimeter. Well, okay, so one thing to notice is this is a little bit smaller than the values on this range. So either our resistor is a little bit out of spec, or our multimeter has measurement uncertainty that's greater than 1%. So the actual resistance might be actually on this range, but our multimeter is giving us a measurement that's a little bit smaller than that range. All right, let's do another one. All right, so here's a resistor. Again, it has 5 color bands. The tolerance band is again brown. But here, the colors are orange, white, black, brown, and the tolerance band is again brown. So what do these represent? Well, orange is 3, white is 9, black is 0, brown is 1. So here we're dealing with a resistor that's 390 times 10 to the first, the multiplier band, plus or minus 1%. So that's 3,900 ohms plus or minus 1%. So we should expect this resistor to have a resistance between, so 1% of 3,900 is 39. We should expect the resistance to be somewhere between 3,861 ohms and 3,939 ohms. All right, so again, let's measure it using the multimeter and see what we get. All right, so here's my multimeter. I'm going to set it to measure resistance. Get my leads. Put the red lead on one side, the black lead on the other side, and measure the resistance across this resistor. I get 3.91 kiloohms, 3.91 kiloohms. So the actual resistance was 3.91 kiloohms, or 3,910 ohms, which is pretty much spot in the middle of that range. So the measured resistance and the expected resistance match up. Okay, so what am I going to expect you to be able to do? Well, I'm going to expect you to be able to, if I give you a resistor, to determine the colors of the bands, including the color of the tolerance band. So you got to identify which of the bands is the tolerance band. And again, it's always going to be the one that's a little bit, this is hard to determine sometimes, the band that's a little bit further away from the other bands. And then I will give you the color code, which means I will tell you what digit each color represents. Let me show you what I'll give you on the exam. I'm going to give you this information right here, which shows you the digit that each color represents. I will not give you this information up here, which shows you how you then take those colors and the numbers they represent to determine what the actual resistance and tolerance is. So I will not tell you that the last band before the tolerance band is a power of 10. It's a multiplier band. All right, I will expect you to know that, and I'll expect you to know the last band is the tolerance band. All right. So if I give you this picture, or just tell you the colors of the bands for a resistor that would look like this on an exam, I'd expect you to be able to then use the color code that I give you to know that brown is 1, green is 5, orange is 3, and that orange band is the power of 10 multiplier band. So the actual resistance is 1/5 times 10 to the third, or 15,000 ohms, And the tolerance band here is gold. Gold means 5%. So the resistance is 15,000 plus or minus 5%. If I gave you a picture that looks like this, I'd expect you to figure out that brown is 1, green is 5, black is 0, red is 2. So here we have 150 times 10 to the second, which is also 15,000. So this picture is showing that you don't always have the same number of bands. Some resistors have the resistance encoded with 3 bands, and others have the resistance encoded in 4 bands. Use the same process either way. The last of the color bands, not counting the tolerance band, is the power of 10 band. All right, so that does it for this lesson. You'll get a little bit more practice doing that.